Let's talk about modeling one-step equations. So you have in front of you some algebra tiles, and I have my digital ones. So the algebra tiles represent the following things. Your physical algebra tiles are green and red, and tan and red depending on the piece, but the bar represents a positive x, and the red bar will represent a negative x, and that x is representing an unknown quantity or variable. For the little squares, this is a positive unit, or 1, and this is a negative 1, negative unit. So the bars represent the variable x, and the squares represent units. The red side is negative, the other side is positive. So let's talk about how we write an expression. So an expression is a number sentence that does not have an equal sign. So this first one, we have two x's that are negative, so we're going to write that as negative 2x. And then we have 4 positive units, so we're going to write that as a positive 4 or plus 4. So the expression is negative 2x plus 4. So then what happens if the units are negative? So again, we have some negative x's, but this time we have 3. So we have negative 3x's. And then we have 8 negative units. So to represent negative units, we would write negative 8 or minus 8. So this would be negative 3x minus 8 would be our expression. So now let's talk about what happens when we have an equation. So you'll see right here in the middle, we have an equal sign, which means that the left side has to balance and equal the right. So on this particular example, we have 3 x's that are positive, set equal to 12 positive units, and they're positive because they're not shaded red or shaded in at all. So 3x's is equal to 12. So that is our beginning equation, which we're going to write over here. So 3x is equal to 12. Now, using your algebra tiles, this is how you would show your solution. So I have my model right here. I have my 3x's and I have my 12 units. So what you're going to do is you're going to see how many units would be set for your x's. So I'm going to get rid of my equal sign, and I am going to move my algebra tiles around and distribute the units to each of these bars to see how many would be at each x to figure out what 1x is equal to. So the goal when we are doing equations is to figure out what 1x is equal to. So in this case, if you're looking at our picture, once you move your stuff around, we have this right here is 1x is equal to 4 positive units because it's distributed evenly. So each of these has 4 units. This is your x. So x is equal to 4. So when we distribute to equal groups, that's actually division. So the way that we show this mathematically or algebraically, 3x is equal to 12. Our coefficient is attached to the variable. That's what we are going to divide both sides by. So divide both sides by 3. This leaves us with x. 12 divided by 3 is equal to 4. So our solution is 4. And this is how we can check it. So our original equation was 3x is equal to 12. Instead of x, I am now going to rewrite it with our solution, which we said was 4 right here. So we know that 3 times 4 is 12. 12 equals 12, therefore it works. So x is equal to 4. And then if we were going to do the number line, we would just plot a point at the 4 on the number line and just get a closed circle because that is the solution. So now let's do one with negative units. So we have 4 positive x's is set equal to 8 negative units. So we're going to write that as negative 8. So our equation is 4x is equal to negative 8. Again, we know that 4x's is equal to 8 negatives, but we want to know what 1x is equal to. So I'm going to move them around like I did on the first one. So I'm going to move my x's so that I can then move my units and share them equally between the x's until I have no more left. So in this case, 1x is equal to 2 negative units. So x is equal to -2. Algebraically, we do the same process that we did before. So we have 4x is equal to -8. I have a coefficient of 4 in front of the x, which means that is connected by multiplication. So to undo that, we divide both sides by 4. So then we have -8 divided by 4, which gives us a quotient of -2. Then I can plug it in and I can check. So we had 4x is equal to -8. If I replace that x with -2, we need to see if that gives us a balanced equation. So -8 does equal -8. Therefore, -2 is our solution. And to put it on the number line, we plot -2 and we put a closed circle at that position. Last example that I'm going to do with you is we have 2 negative x's. So -2x is equal to, we have 6 negative units, so -6. So our equation is -2x is equal to -6. Again, we know what 2 negative x's is equal to. So if I move my pieces around, I can see what 1 negative x is equal to. So I'm going to split these up evenly. And when I split them up evenly, you will see that I have a negative x is equal to -3. However, I don't want my solution to be a negative x. I want my solution to be a positive x. So what we have to do is we have to turn these into their opposites. So what you would do with your algebra tiles is you would simply flip over the x and then flip over the units. And if whatever side the units were originally on, they would turn into their opposite. So I can take these and replace. And now I have 1x is equal to 3 positive. So they both became positive because they were both negatives and they became their opposites. However, if the x was negative and I had positive units, I would flip the x and the units, and I would get x equals some negative units. So you'll see that on some examples that you'll do here in a little bit. So let me show you mathematically why they turn positive. So algebraically, we have -2x is equal to -6. Divide both sides by the coefficient of -2. So again, this negative sign is attached to the coefficient 2. So when I divide both sides and I do a -6 divided by a -2, I get a solution of +3. So then when I go through and check my solution, I need to see if that solution of 3 would give me a balanced equation. So we know that -2 times 3 is a -6. We know that -6 is equivalent to -6, so therefore it is a balanced equation. So 3 does work as my solution. So now what you're going to do is you're going to write the corresponding expressions for these problems right here. Then you are going to tell me what the equation is for each of these. And then I want to know what the solution should be. Don't write these actual numbers in here because those are not the numbers, but you're going to go through and give me all those answers at the end of the video. So go through, do the right side page, put your answers into the video, and then upload a picture of your completed page.